Okay, good morning, everyone. This is me again, Dr. Shalilo Amihan, your professor for Advanced Research Methodology and Statistics with Computer Application. I just hope that you have already installed the SPSS installer that I uploaded in our Google Classroom so that you could follow and you could try for yourself on how to compute or on how to analyze quantitative data using that software. Allow me to share my screen. So say for example, your topic for your research is motivation and study habits as predictors of academic performance. The paradigm of this would be cause and effect. So that would be your general methodology is quantitative. Specifically, it's causal relationship or cause and effect relationship between the variables motivation and study habits versus academic performance. For my statements of the problem so that I could answer this main question of mine is what is the profile of the students in terms of gender, year level? That's my first SOP. The second SOP would be what is the level of motivation? If you could notice, that would be your first variable indicated in your title. Another is what is the level or what is the study habits of the students? This is also another variable in your study. And then what is the level of academic performance of students? And this is your dependent variable. We also have other sets of questions relevant to our study. Number 5 question is there a difference in the academic performance of students when they are grouped according to profile? You would want to know whether males and females differ in their academic performance. You would also want to know whether students of different year levels differ in their academic performance in here. Another SOP, which is your main statement of the problem, is do motivation and study habits predict academic performance of students? And that really is your main statement of the problem. That's your main goal for your study. You would want to know whether both the variables motivation and study habits actually predict or influence academic performance. You only have here two SOPs that would be answerable by yes or no. And these are SOPs that need to have hypotheses. So your hypothesis corresponding to your statement of the problem number 5. There is no significant difference in the academic performance of students when they are grouped according to profile. This is according to this. We would be stating the null hypothesis. Null means there is no. On another hypothesis corresponding to your SOP number 6, motivation and study habits do not predict academic performance of students. So you only have two hypotheses that you need to answer statistically whether you accept or reject the null hypothesis. Say for example, in your questionnaire, since this would become a survey, in your measurement for motivation, you only have 8 items or questions in your questionnaire. Each item will be rated by the students from 1 to 3. For study habits, there would be 10 items, same also rated 1 to 3. For academic performance, there's no questionnaire really for this, but you would be getting data from the general average of the students based on official school records. The sample size for this study is 82 respondents. Now, what you need to do first, of course, is to gather the data, the accomplished, the answered questionnaires already. You have 82 all in all based on their answers on profile, motivation, study habits, and academic performance. And you need to tally them, encode them in Excel form. Okay, I want to highlight tally them in Excel form. This is a sample of a tally for this particular case. If you could see in here, there are so many values, so many numbers, but you have here on the first column, respondent number. Okay, it should be until 82 since we have 82 respondents. That's your sample size. For the gender, you need to code. In this case, I inputted 2 for female, 1 for male. So for respondent number 1 is a female, I encoded here 2. The general weighted average, I would encode for her 89. The year level is 3. The course is coding, but it's not really relevant to our discussion right now. Now, when you talk of motivation, this is motivation, you actually have 8 questions under motivation. I just labeled it from A1 until A8. Each response of the first respondents should be tallied in here. So for question number 1 of motivation, the answer is 3. Next is 3, 3, 2, 2, 3, 1, and 2. That's for the 8 questions of motivation for the first respondent. Going into the study habits, there would be 10 questions all in all. Same rating, 1 to 3, based on the responses of the first respondent. The answer is 3 for question number 1 for study habit, 3, 2, 2, 2, 3, 3, 3, 1, 3. You're already done with the first respondent. You do that for all the respondents until the 82nd respondents so that you would have this kind of tally sheet. What you need to do next is compute for motivation and study habits, since these are individual questions that would reflect motivation. These are individual responses that would reflect study habits. So what you need to do is compute for the average from A1 response to A8 response. So you click here, you type average, click average, and then you would drag from this to here. Then you click OK. So 2.375 is the average reflecting the level of motivation for the first respondent. All you need to do is double click this one so that it would automatically compute for the entire tally sheet. Now, you would do the same for study habit. You would compute for their average, okay, for the average, and then you would click here and then drag until the responses for B10. Click OK. 2.5 is the level of study habit for respondent number 1 based on her responses from the first question until the 10th question. All you need to do is double click this one so that it would reflect to the entire tally sheet. Now that you already have your tally sheet, all you need to do is save this one, okay, and then try to close. Now, since you already have a tally sheet, all you need to do is compute using your SPSS. If it has already been installed, what you need to do is click the icon for the SPSS software. It would open up, and then you try to navigate and answer the questions that you have from statement of the problem number 1 until statement of the problem number 6, particularly focusing on answering the hypothesis. Now, you would have this kind of window when you try to open the SPSS. What you need to do is open an existing data source, which you save. You click OK in there, and it would ask you to find the data file that you have, the tally sheet that you encoded. Just click here the files type. I'm sorry. Click here. Rather than SPSS format, you try to click and look for the Excel format. And then you try to look for the file where it is located. I saved it in here, and the file name that I used is sample tally for SPSS lecture. You click open, and then it would be now transferred to your SPSS software, the data that you encoded. Now, this would be the appearance. If it would be in the variable view, you could also click here the data view. It's just the same with the Excel file that you migrated. Now, let's try to answer first SOP. What is the profile of the students in terms of gender and year level? You would want to know how many males, how many females, how many first year, second year, third year, and fourth year. It's because in this example, I have from first year until the fourth year students only. Okay, so let's try to go back to our SPSS. What you need to do is click Analyze in here. Click Analyze, and it would ask you what to do. Since your question is describing, okay, when you try to describe, it's descriptive statistics, and you would click here frequencies to know gender and to know also the year level. Click frequencies, and you have here gender and year level. You click the gender, and then you transfer that in the variables. Click also the year level, and you transfer that to variables. When you click OK, what would appear is the result already of your statement of the problem number 1. Question: what is the profile of the students in terms of gender? You have here the result for gender. It would just simply state that for number 1, which is male, you only have 34 respondents. That would be 45.1% of the total. For female respondents, you have 45, comprising 54.9. So you could say you have more female respondents compared to the male respondents. With regards to the question, profile in terms of year level, you could see there's only 1 from the first year, 46 from the second year, 30 from the third year, and 5 for the fourth year. All you need to do is copy this and paste in your Word file so that you would have your table to answer a particular statement of the problem already. Now, going forward, the next question is, what is the level of motivation of the students? Let's try to go back with our data. Click Analyze. Still on the descriptive, it's still asking what. So you would click here descriptive statistics, but rather than frequency, you click descriptives. What you need to do is compute for the mean. Now, you just click all the statements, including the computation for the average for the first variable, which is motivation. Motivation is A1, A2, A3, A4, A5, A6, A7, A8 until motivation, and then you transfer them to this side. You click OK, what would come out would be this kind of data. It would just simply say that for the first question on motivation, the mean is 2.52. For the second statement, the mean is 2.34 and so on. The general mean really is 2.26. So those are the answers for your question on the level of motivation of the respondents. The next question is on study habits. Question number 3. Same with what we did with the level of motivation. Let's try to go back to our data. Click Analyze. Descriptives, and then another descriptives. Rather than motivation, you try to reset, and then you go for B1, B2, B3, B4, B5, B6, B7, B8, B9, B10, and then study habits in general. Transfer them to the variables box and then click OK. And you would have this kind of result. This would answer the level of study habits with regards to item number 1. But in general, you would have 2.301. It's in here. Now, you already have answered SOP number 1, number 2, and number 3. Next question is, what is the academic performance of students? It's still a question of mean. You try to go back to your data and then click Analyze and then Descriptives. Then you try to describe, reset, click for the general weighted average. Transfer it in here and you click OK. The result would be like this. The overall mean is 86.52. The highest score or grade is 97. The lowest grade is 75. That's with a standard deviation of 3.99. Now you have already answered number 1, 2, 3, and 4. We would now proceed to analyzing the data so that we could answer number 5 and number 6. For number 5, is there a difference in the academic performance of the students when they are grouped according to profile? You would ask your statistician for this. The choices for statistical tools to be used would really depend on the number of groupings. Since profile is gender and year level, gender only has 2 groups. We would be using t-test for this case. For year level, we would be using analysis of variance. It's because it has more than 2 groupings. So let's try to go back to our data, click Analyze, and then you are trying to compare the means. The question is difference. Is there a significant difference in their academic performance when they are grouped first according to gender? And since it has 2 variables, you would be using t-test, independent samples t-test. So you would click here, independent samples t-test. You would be asked for the grouping variable. The grouping variable is the gender. You would also be asked on the test variable. The test variable is the academic performance or the general weighted average. That's based on our statement of the problem. Then you transfer the general weighted average in the test variable. Okay? Take note here that in the gender, you would be asked with the question, what are the groups for gender? You click define groups. You only have group 1 and group 2, males and females. You type here 1 and then 2. Then you continue. When you try to click OK, this would be the results. This is the descriptive statistics showing the mean for academic performance for males, that's 1, which is 84.89. The females, that's 2, is 87.87. If you could see, there is a difference. Females have a slightly higher academic performance compared to the males. However, the question is the difference enough to say that there is a significant difference? And we would determine that statistically. So you try to go to this table. First, you try to look for the values for Levine's test for equality. Look for the sig, this one. If the sig is greater than 0.05, therefore we would say that there is no significant difference. But that's not yet the answer for our question. This is just used so that we would know whether there is equal variance that can be assumed or it could not be assumed. Since this is greater than 0.05, the number that we would be looking would be uh, equal variances assumed. You would be confronted with two data in here, 0.001 and 0.001. Well, it does not matter. They have the same value, but we would be getting this top value. It's because it would reflect equal variances being assumed. The answer is 0.001. Okay, let's type it here. With regards to this, it's 0.001. The result is actually lesser than 0.05. We would always use 0.05 as our point of reference in determining whether we accept or reject a particular hypothesis. In this case, our computation is 0.001. We would try to compare it with 0.05. The rule is if it is lesser, if the computed value is lesser than 0.05, therefore we could say that there is significant difference. This is our answer with regards to gender. So is there a significant difference in the academic performance of students when they are grouped according to profile? With regards to gender, there is a significant difference. And if we'll try to go back to our figure here, 87.87 and 84.89, the difference is significant enough that we could say that males and females differ or vary in their academic performance. So that settles it. Now, how about for year level, since we have that kind of question? We try to go back to analyze, compare means, but instead of independent samples t-test, we would be using analysis of variance. Why? There are more than two groups involved in here. Unlike gender, you only have male and female. Now you click one way ANOVA, and then same dependent list would be the general weighted average. It's because that's your question, but you try to compare the academic performance through the general weighted average when you try to group them according to year level. Just click here, year level, and then you click OK. When you click OK, this would be the result. It's just a very brief table. Again, you would be looking at the SIG, the data for SIG or SIG. This would also mean your p-value or the computed p-value. The score is 0.727. Let's get back here. 0.727. Am I right? Is 727. Okay, this one. 727 is greater than 0.05. Therefore, we would say there is no significant difference when you try to compare them by year 11. Okay? So with regards to the first hypothesis, there is no difference. It is supported when you try to compare them by year level, but it is rejected when you try to compare them by gender. Now you have already answered your statement of the question number 5. Let's try to answer your main question. Do motivation and study habits predict academic performance? Let's try to go back to our data. You click analyze, and for this you would be using regression. It's because it's prediction or cause and effect. Click regression, you would be using linear regression. Click linear. Your dependent variable is academic performance. Your independent variables are motivation and study habits. So you transfer general weighted average for academic performance in the dependent variable. Okay? You transfer in your independent variables the score for motivation and the score for study habit. Okay? You click here statistics so that you would see and add more data. In statistics, you check estimates already, model fit, but you need to check also R square change. This one, so that you would know the overall effect. Then you click continue and then you click OK. Now, this would be the results of your analysis for your question. Do motivation and study habits, influence or predict academic performance? Okay, it just simply state here as a summary, the dependent variable that you did is general weighted average, and then your variables as dependent or independent variables are study habits and motivation, these two in here. Okay, let us try to look the model summary. This is actually the overall result already. Trying to look at what is the overall effect. Is the overall effect enough? You look here at the adjusted R squared. This is the adjusted R squared. 0.043. 0.043 would translate 0.4% or 4%. So you would say 0.4% change in the academic, no, it's 4%. I'm sorry for that. 4% change in the academic performance is because of the effect of combined level of motivation and study habits. So it's just very minimal. 4% change in the academic performance can be predicted by both student or study habits and the level of motivation. And it actually is not significant. It's because it's 0.067 in here. However, let's try to look at individual effect. What if it's just study habit alone? What if it's just level of motivation alone? Would it significantly predict academic performance? And to what degree? What percent of change would it do? Okay, let's try to go back to the table that we have and look at the final table. Okay, you have here SIG table, and you have here also the table for motivation and study habit. Let's try to look at the SIG. Same rule versus 0.05. You try to look at here only the two data. One is 0.027. Let's transfer it here. you have for motivation first, and we have for study habits. The result for motivation is 0.027. Okay, let's type here 0.027. For study habits, let's try to go back. Study habit, the result is 0.647. 0.647. You try to compare this with 0.05. Definitely this is lesser than 0.05. This case, this is greater than 0.05. You'll try to interpret this as motivation significantly predicts academic performance. So, motivation significantly predicts academic performance. However, for study habits do not significantly predict academic performance. Okay, so therefore, with regards to the question, do motivation and study habits predict academic performance? When you try to combine the two, it does not predict academic performance. Why? It's because in the previous data, it only yielded 0.067. This one, it's greater than 0.05. The answer is it does not predict academic performance. It does not have a significant effect. However, when you try to look at them individually, motivation versus study habits, motivation it's lesser than 0.05. Study habit it's greater than 0.05. Therefore, we could say here, only motivation significantly predicts academic performance. Why? Because 0.027 is lesser than 0.05. While on the other hand, study habits 0.647 is greater than 0.05. Now, you have already answered the question. Do motivation and study habits predict academic performance? However, in motivation, it predicts academic performance. But the question now is, to what extent? What is the power of its influence? You try to go back here again. You try to look for standard coefficients beta. Look at this data. It's 0.280. We would only look at the data for motivation. It is because it is the only variable that has a significant effect. 0.280 is translated as 0.280 is also equal to 28% change on academic performance is actually based on motivation. Therefore, we could say motivation predicts 28% of the change in academic performance. Okay? So try to summarize everything. With regards to profile, we already determined that there are more females compared to males. In the year level, it varies actually. In the level of motivation, we have answered that through the mean. Study habits, answered that through the mean, including the academic performance. We already answered which is minimum and which is maximum score for that. With regards to the question, is there a difference in academic performance when they are grouped according to profile? The first profile is gender. The answer is there is a significant difference. We have that kind of conclusion is because the data 0.001 is less than 0.05. However, in year level, there is no significant difference. It's because the data that we got is 0.727, which is greater than 0.05. With regards to the question, do motivation and study habits predict academic performance of students? For motivation, the answer is yes. It significantly predicts academic performance. We answered it that way. It's because the data of 0.027 is less than 0.05. Furthermore, it could predict 28% change on the academic performance. On the other hand, study habits does not predict academic performance. Why? It's because the value of 0.647 is greater than 0.05. Okay? So that's how we try to analyze the data using the statistical software package for the social sciences. I just hope that you learned a few things about data analysis, trying to connect it with application to research methods. This is just a sample. You could actually try it on your own, but of course, you would have your advice, you would have your guidance from your statistician. So it won't really be much of a problem. I would request for you, however, to try on your own. Try to solve on your own. I'll try to forward you a sample data also, the one that I used right now, so that you could test and check whether you would have similar results with mine. And you could actually practice and learn on your own. So that's it for this session on how to use SPSS software in analyzing quantitative data with this kind of example. Thank you for listening and good day to everyone.